Okay, question 2. Binary numbers can be converted to hexadecimal. A. Convert the two binary numbers to hexadecimal. Okay, so the thing to remember with converting when you're working with binary and hexadecimal is the binary numbers you write will be written in nibbles. So that's when you go and write out the nibbles. A nibble is just a group of 4 bits. So if we take our first number, we've got 100, 100, 11. What we're going to do is we're going to write this number in our nibbles or groups of 4 bits. We start from the bit with the least value or the least significant bit, which is always the one on the right hand side. So let's go 1, 2, 3, 4. We'll leave a gap. 1, 2, 3, 4. Then we just need to write a small table above each one. So that's our place values 1248, 1248, and then we can convert each of these into a number. So that's 3, 2 plus 1, that's 8 plus 1, which is 9. So that's our first answer. So we're going to write that here, 9, 3. Really important tip for the exam, do not change the order of these. Quite often in the exam somebody might write 9 and 3, work them out correctly, but they're the wrong way round then. So we keep these in the same order. Now the second number, we have 0, 0, 0, 0, 1, 1, 0, 1. Let's go ahead and write that out again, starting from the least significant bit. We got our first nibble, or first 4 bits, and then our second 4 bits. Right, let's pop a table above these. So 1, 2, 4, 8, 1, 2, 4, 8. We can convert our first nibble, which is 0. Our second nibble is 8 plus 4 plus 1, which is 13. Now, we have to replace each of these nibbles here with a single digit. Now 13 is not a single digit, so the hexadecimal counting system, so if we go denary 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14 and 15, in hexadecimal, as you will know, the first 9 digits are the same. But once we get to 10, we need to replace 10 with a single digit. So that is A, which I'm pretty sure you will already know. And then all the way down to 15, which is F. In the exam, another tip, I would recommend writing this table out. So you're not relying on your memory or trying to work it out in your head, because it'd be a silly mark to lose. Because quite often somebody may say 13 is E or 13 is C. But we know, by doing this, we know 13 is D. So we'll replace 13 with D. Now we've got 2 digits here. It says convert the 2 binary numbers to hexadecimal, and if these numbers were stored in a register, we would need this. So technically 0D is just D, but because they've given us this full binary number here, I'm going to include it in the answer, and it is in the answer scheme. So technically D is the same as 0D, but we've converted 0000 as they've asked us to do. So if we look at the mark scheme, 1 mark for each correct character in the correct order. So we've got 9, 3, which we're happy with here, and then 0D. Right, okay, let's stop this one and then we'll go on to part B.